All right, so maybe you've worked with binary trees before, maybe you haven't. This should be useful either way. And maybe try this one out, and we'll jump right in. So the way they give you the input might be a little misleading for first timers, although this is useful to visualize. In reality, what they're giving you is, so I'm just going to put a tree node, standard. If we actually wanted to construct this binary tree, we would do something like this. So what they're giving you when they give you the binary tree is really this. And I'm actually going to draw that out so it's a little cleaner looking. So we'd have our object, and we'd have val as our property, value of 1, and then we'd have to the right, we'd have another object, value 2, and to the left of that guy, we have another object with value 3. So something like that. Notice how I didn't put in all the null values, just to make things look a little prettier. Yeah, just for clarity's sake. But yeah, when you think about what they're actually giving you as a binary tree, although this is nice to look at, this is what we're actually getting. So it might be helpful to have when we're walking through this one. And speaking of this one, let's just go ahead and code it out. Let's say our stack. If you never worked with a stack before, it's pretty easy. It's basically just, we're only really going to take off the top. Basically think of any other sort of stack, a stack of papers. Read only can grab what's off the top. We're going to say, well, we have a root, or we still have something in our stack. Oops. If it's a root that we have, we're going to push that root onto the stack. We're going to set our root equal to root left. If we don't have a root, we're going to set it to whatever's on the top of our stack. We're going to push. Oh, and by the way, we are going to do it iteratively because I think it's a little more, or a little easier to visualize. And that's what the problem calls for anyway. So there it is. Our output should be 1, 3, 2 because, so in order traversal, the way I like to think about that is, say you had a binary tree that looked like this. Inorder traversal means taking what's all the way down to the left first, then grabbing what's on the top, then grabbing what's on the right. That's the way I like to think about it. So for this one, nothing on the left, go all the way down to the left. So actually first, nothing on the left, so we've got the top. Then we go all the way down to the left on this side of the tree. So you can think about this tree as something, as a whole new tree. So go all the way down to the left and grab that, and then grab what's on top. So we get 1, 3, 2. If that doesn't make sense, you might want to look up binary trees and study them a little more. Or look up Inorder traversal. But for now, let's make sure that's what we get. And we're going to pass in that object that we created, the actual tree. I think that's our problem. Right, it's not defined. Oh, whoops. Root. There we go. So let's walk through how this one works. So let's start by putting our stack up here, keeping track of that. And our result down here. And so when we get this whole object at the start, we're going to say, while there's something there, so yes, we immediately jump down to here. If there is something there, yes, push whatever's at our input. So whatever we got as an input, push that into our stack. So that's going to be this whole object now. It's going to be inside of our stack. So I'm not going to rewrite that, but just imagine that. And then our root is now whatever is at root.left. So root's here, and now we're at root.left, which would be null because we only have stuff to our right. So let's keep that in mind. Now we go back up here again. While we have something as our root, we don't because it's null. Or we have something in our stack, which is true. Jump down here. If it's our root that we have, no. So we pop back out this whole object. Basically all we did was check if anything was to the left there. There was nothing, so we have our object back in our hands. So now root equals stack.pop. Root equals the whole object. Just visualize that. This whole object is now in root. And we're going to say push root.val. So the value of our root is 1 at this point. So we're going to put 1 there. And then we're going to set our root now to root.right. So root.right is going to be this whole part of the object, or this whole new object. So from here to the end. So if you can just imagine that, let's just do this. Just as simple as that part. So now, while root, so we do have something as our root, check down here, push our root into the stack. So push this whole part in there. Because we want to keep track of that. And then we're going to set our root to root.left. And root.left is going to be this whole part. I know it's a little ugly, but you get it. Now we go back up here. While we have something as our root, we do push what's in our root onto the stack. So push this onto the stack. And we say now our root is equal to root.left, which we don't have. So our root's null. Go back up here. If we have a root or something on our stack, we don't have a root, so we go down here, stack.pop. So pop is going to grab us what's the last of our array. So we get back this. We pop that. We push. So now our root is equal to stack.pop. So this part of our object and pop also actually removes that element too. We're going to push its value into our result. So this, the value of this, which should be 3, I'm going to push that into here. And we're going to set our root to root.right. So we're still here, but root.right is nothing, so that's null. So still have something in our stack. If something's in our root, nothing's in our root right now. We pop off what's in our stack. So now our root is equal to what's in the stack. Boom. So this whole part. So we push our root.val. So root.val would be 2. And our root is equal to root.right now, which doesn't exist because, so if you're imagining this, we're right here right now in 2, this whole part. And we're saying root.right, which is null. We don't have another right here. And now we go back up to the while loop. While we have a root, no we don't. While there's something in our stack, there is not, so this while loop ends. We return what's in here, and that's how we get the right answer. So hopefully that makes a little sense walking through it like that. You can kind of see how this stack allows us to jump down to what's all the way to our left. And then if there's nothing there, or if you already pushed onto the stack what was there, then we jump back up to the node. So once again, if we're here, we check here. If there's nothing there, we jump back up to here, and we return that, pop that off our stack, and return its value. And then jump back up here from what's in our stack, and return that value before going down to the right and doing the same thing. So hopefully that makes a lot of sense now, having walked through it. And yeah, I hope this video was helpful as always.